Hello, boys and girls. My name is Erica Allen Charles, and I am here today to help you with your mathematics session. Our topic today is fractions. I know it's a topic that's a little bit tricky, so I will take my time, I promise you. What is a fraction? A fraction is a part of a whole, but I know that you know that, and you also know the different types of fractions as well. Proper fraction, where the numerator is less than the denominator. An improper fraction, where the numerator is greater than the denominator. And a mixed number, where you have a whole number and a proper fraction. But today, I want you to pay attention because we're going to look at something special, equivalent fractions. I have here a beautiful model of a whole. If I were to remove this part, then I have 1/2. I wonder how many quarters will make up 1/2. Let's see. Two quarters. So we can say that 1/2 is equal to 2 quarters. Let's try eighths. One, 2, 3, 4. So clearly we can see that 1/2 is equal to 4/8. I want you to look with me at the fraction chart. This fraction chart is very, very similar to that model there. We have the whole, then we're dividing into halves, quarters, eighths, and 16ths. Look at 1/2. What is the equivalent fraction for 1/2? Come down with me. 2 quarters. Yes, let me write it down. Let's go back to 1/2 again. We're coming down to the eighths now. 1/2. Let's count. 1, 2, 3, 4. 1/2 is also equal to 4/8. Are you seeing the similarity? Let's go one step further. How many 16ths? How many 16ths? Again, 1/2 coming all the way down. Count with me. 1, 2, 3, 4, 5, 6, 7, 8. 1/2 is equal to 8/16. Do you know something? We can try this with another fraction. Let's say 3 quarters. Count with me and let's see how many eighths are equivalent to 3 quarters. First, let's get the 3 quarters. 1, 2, 3. Let's come down. And we are going to count now. I wonder how many eighths there are. Count with me. 1, 2, 3, 4, 5, 6. So we can say that 3 quarters is also equal to 6/8. Might I challenge you? Might I challenge you? What if we do it in the reverse? What if I were to ask you to identify 4/16 and to see how many eighths there are? Do you know that you can go up and down the fraction board, or the fraction chart in this case? Let's try it. Let's get 4/16. 1, 2, 3, 4. Let's go up now. Let's count how many eighths. 1, 2. So I am seeing, or I'm bringing it to your attention, that you can do it the opposite way as well. So we are saying that 4/16 is also equal to 2/8. Isn't that interesting? Isn't that interesting? I want to take you one step further. What if we did not have the fraction board? What if we did not have this model here? If I were to ask you to look at the fractions and see if you can come up with a way that you can get the equivalent fraction, what would you say? Let's look. 1/2 is equal to 2/4, 1/2 is equal to 4/8, 1/2 is equal to 8/16. Let's start with this side first. What if I multiply the numerator and the denominator by the same number? Let's try it. One times 2 is equal to 2. 2 times 2 is equal to 4. Let's verify. Let's try another. One times 4 is equal to 4. 2 times 4 is equal to 8. Let's keep going. 1 times 8 is equal to 8. And 2 times 8 is equal to 16. I'm seeing a pattern here. I am seeing a pattern here. It seems to me that when I multiply the numerator and the denominator by the same number, guess what? We get an equivalent fraction. Let's look at this special one here. Remember, this was the one we did in reverse? What can we do to 4/16 to get 2/8? Do we multiply? I don't think so. What about doing the reverse? What about dividing? Let's try it. What number are we going to try? Does it hold? Yes. 4 divided by 2 will give me 2, and 16 divided by 2 will give me 8. So clearly we are saying that to get equivalent fractions, we can either multiply the numerator and the denominator by the same number, or we can do the reverse. We can divide the numerator and the denominator by the same number. Aren't equivalent fractions fun? They are, you know. But you know what? I want you to pay attention to this, because I have 2 problems. You're going to take them one at a time. And I want you to see how best you can solve these problems using equivalent fractions. Let's look at question number 1. Read with me now. John and Ken are arguing over the number of fish they own in a tank. John owns 7/16 of the fish, while Ken owns 1/4 of the fish. Which brother owns the greater fraction of fish? So let's look at this problem. First, we identify what each brother owns, what fraction that is. John owns 7/16. His brother owns 1/4. The question is, which brother owns the greater fraction of fish? So what we need to do is to apply what we just learned, equivalent fractions. Let's see. We have 7/16. I'm pulling them out. We have 1/4. What can we do with this? Is one a multiple of the other? Can we use a method where we can get both of them being equivalent fractions with the same denominator? 16 seems to be a multiple of 4, if you know your 4 times tables. Let's try to change 1/4, and let's see what we get. Applying the same principle we did before. What number am I going to multiply by? 4 times 4 is equal to 16. What did I say before? What you do to the denominator, you must do to the numerator. We are going to multiply the numerator by 4. So we can say that 1/4 is equal to 4/16. Now that both denominators are the same, we can compare. John, his brother. Let's go back to the question now. Which brother owns the greater fraction of fish? Well, I think John has won this battle because John has 7/16 while his brother only has 4/16. Remember, we are looking at the numerator to tell us how many parts there are. John won this one. So John is the brother with the larger or the greater fraction of fish. Let's look at question number 2. Read with me now. Lisa received 2/5 of a pizza and her brother Mark received 3/10. Mark says that he received the larger fraction. Is he correct? Give a reason for your answer. Well, to determine if Mark is correct or not, again, we have to do what? Equivalent fractions. Why? Because the two fractions are different. Let me pull them out. Lisa received. Mark received. We follow the same format. We cannot compare the fractions because both of them have different denominators. I think you're catching on, you know. I think you're catching on. We need to do something with one of the fractions. Is one a multiple of the other? Let's see. Isn't 10 a multiple of 5? So therefore we can find equivalent fractions of 2/5. Let's do that now. Remember, we want to change the denominator to tenths. Five times 2 is 10. What do we do with the numerator? Do you remember now? Of course you do. Multiply by the same number. 4/10. So Lisa received 4/10. Mark received 3/10. Let's go back to the question. Mark says that he received the larger fraction. Is he correct? Clearly, Mark is wrong. Lisa received 4/10. Mark received 3/10. Give a reason for your answer. The answer is clear. After applying equivalent fractions, we can clearly see that Lisa has the greater portion. Boys and girls, clearly we can see that we can apply equivalent fractions in any situation. Oh yes, we can. This is a very, very important skill that can take you very, very far. So what I want you to do is to practice doing equivalent fractions. Don't be afraid of them. They are your friend. let's go over what we did today. We realized that we can find equivalent fractions on a fraction chart. We can even use an area model. But we also came up with a rule to find equivalent fractions. And what is that rule? Can you remember now? Let me help you. We can multiply the numerator and the denominator by the same number, or we can divide the numerator and the denominator by the same number. Don't forget, practice your fractions. Now we are going to go a little bit further. Would you like to do that with me? Can you remember how to add fractions where the denominator is the same? I bet you can. I bet you can. When you add fractions, when the denominator is the same, we focus only on the numerators. Do you remember that? And the denominators remain the same. Let's try it and see. Come with me to the board. We have 1/4, add 2/4. I wonder what the answer would be. 3/4. Do you want proof of this? One quarter add 2/4 gives us 3/4. Remember now? Let's look at the next one. 3/10 add 4/10 will give us what? I bet you know. 7/10. And the last one. 2/8 add 3/8 will give us, yes, that's the answer, 5/8. Thank you for remembering so well. So we can move on. Remember, when we are adding fractions with the same denominator, we only focus on the numerators because the denominators remain the same. We are adding 1/4 to 1/2. Do you think we can add those two fractions just like that? Of course not. I know you remember, and something is coming to your mind right now. Equivalent fractions. You are so correct. Equivalent fractions, because we remember that we cannot add any fractions when the denominators are different. We must bring them to the same denominators. So what are we going to do? Let's observe. Is 4 a multiple of 2? Children, are you seeing a pattern? So we can change one of these fractions here. Which one? I'm waiting. Yes, 1/2. We can change 1/2 to equivalent fractions where the denominator is 4. Let's try it. Remember what to do? So 1/2 is equal to 2/4. This 1/4 remains the same because he already has that denominator. We don't touch him. So let's bring him down. So in truth and in fact, we now have 1/4 added to 2/4. What's my answer, children? Yes, you are correct. 3/4. By using equivalent fractions, we can compare these fractions and get the answer by adding them when the denominators are the same. Do you want to try it with another question? Let's do so. Different fractions this time. Same principle. Can we add like that? No, we can't. What do? Apply the skill of equivalent fractions. Is one a multiple of the other? Let's observe. Yes, 9 is a multiple of 3, so we can find equivalent fractions. Which fraction are we going to change now? Let's go. Yes, I think you're catching on. Now, let's continue to add. Our answer is 4/9. Remember, we cannot add fractions with different denominators. We need to ensure that our denominators are the same before we add our fractions. When one is a multiple of the other, we just make it into equivalent fractions and then we proceed to add. Now, I want to challenge you. I have a problem which I want you to solve. Can you solve this problem with me? Daddy was painting a wall. He painted 5/16 gray and 1/4 yellow when the paint finished. What fraction of the wall did he complete? We have two fractions there. Let's look at it again. What fraction did Daddy paint gray? 5/16. Let's pull that information out. What fraction did Daddy paint yellow? 1/4. Let's split it out. What is the question asking? What fraction of the wall did he complete? To answer this question, we have to put the fraction that Daddy painted gray together with the fraction that Daddy painted yellow. And when we put those two together, we add them to find out what fraction of the wall Daddy completed. Let's do that now. Remember what we did before? I bet you do. We cannot add these fractions like this. We must get the equivalent fractions. I heard you. Which one will we change? I know by now, some of you have worked it out in your head. You are just waiting to give me the answer. But wait on me. I will solve it. And I'm certain that you have the correct answer. Let's go. One quarter is equal to 4/16. Let's complete the sum. There you have it. I knew you had the answer. You are so correct. 9/16. When we add 5/16 and 1/4, we get 9/16 because we applied equivalent fractions. Good job, children. Great, great job. Can I tell you boys and girls something? Can I? Do you know that there is a similarity between how we deal with subtraction of fractions as we do with addition of fractions? Oh, yes. Now we're going to go into subtraction of fractions. They are so similar. Really, really similar. As long as you have the same denominator, Guess what? It's the same principle. It's the same principle. Let's try it now. Come to the board with me. 7/16, take away 5/16. If I just told you it's the same way we do with addition, what do you think the answer could be? There you go. 2/16. The denominator remains the same. The numerator changes. Let's try the next one. 8/10, take away 7/10. I know you have the answer. Applying the same skills, let's look at it. 5/8, take away 1/4. Are we going to subtract like this? No. What must we do? I'm hearing you. I heard somebody shout it out. Yes, equivalent fractions. Is one a multiple of the other? Yes, it is. And you know what to do. So let's do it together. There we have it, 3/8, just applying the same principle. What we did with addition, we do with subtraction. It's just a difference of the process, but the denominator remains the same. Do you think you can try a quick question with me? I already have it on the board. Let's go. Read with me. Tom had some marbles. He gave his brother 7/12 and lost 1/4 in a game. What fraction of the marbles remained? Let's go through this together. Tom had marbles. He gave his brother 7/12 and lost 1/4 in a game. It means that he no longer has the fraction which he gave his brother and the fraction which he lost. So together, this is what Tom no longer has. Can we do something with that information? Oh, yes, we can. We can add those two fractions together to determine what fraction Tom gave away and lost together. Let's solve this, and I know you know what to do. So 1/4 is equal to 3/12. Are we correct? When we found the equivalent fraction, 1/4 is equal to 3/12. Yes? 7/12 add 3/12 will give us 10/12. This represents what Tom no longer has. He gave that away. But look at the question. What fraction of the marbles remained? In other words, what fraction he still had in his hand? What are we to do? Can you remember what 1/2 represents? It represents the total. So now we have to bring in the 1/2. Now we are going to subtract 10/12 from our whole. Remember, your whole is the total amount. Can you remember what fraction represents your whole? Yes. The fraction that represents a whole occurs where you have the numerator and the denominator being the same. In this case, if our denominator is 12, what do you think we are going to use? You have it. Yes. In this case, 1 whole will be equal to 12 twelfths. So my dear boys and girls, this is the fraction that remained. Now, if you look clearly, we can add another skill here. Remember when we did equivalent fractions before? Look at that. This is interesting. Can we do something here? I think we can reduce it to its lowest form. Is 12 a multiple of 2? Yes, it is. And I know you remember how to do this. 2 into 2, 1. 2 into 12, 6. 1/6. Always remember to reduce your fraction to its lowest form. That is very, very important. Let's try another question. Read with me now. An athlete participated in a triathlon. He cycled 3/7 of the race, swam 5/14, and ran the rest. What fraction did he run? Again, what information is given? We have the fraction that he cycled. We have the fraction that he swam. Can we not put those two fractions together? Yes, we can. So that's what we're going to do now, pull out the information that we have. So we'll combine the fraction that he cycled with the fraction that he swam, add them together. Applying the same skills, equivalent fractions. Let's go. Great. This 11/14 here represents the combined fraction of the 3/7 he cycled together with the 5/14 that he swam. We need to find out what fraction he ran. Do you know what to do? Remember what I said before with the whole? Yes, we are looking at the whole, and then we will take this out from our whole. I'm going to write what did I say about the whole? Remember, numerator and denominator must be the same. I know you know what fraction I'm going to write there. Three 14ths. So the athlete ran 3/14 of the race. Children, today we looked at addition and subtraction of fractions, putting them together. It's not so challenging, is it? If you take your time and apply the strategies, I am telling you, you will master fractions. Fractions are your friend. Remember that. Boys and girls, our final question. Yes, we are almost to the end. Let's read this question together. Joe tiled 1/3 of his kitchen floor on Monday and 4/9 on Tuesday. He tiled the rest on Wednesday. What fraction did he tile on Wednesday? Based upon the other two questions, I am almost certain, I know that some of you have your pencils and papers and working it out feverishly. Let's do it together now. What are we going to do? One, what information do we have? We know that he tiled 1/3 of the floor on Monday. We also know that he tiled 4/9 on Tuesday. We know nothing about Wednesday. So we shall combine Monday and Tuesday together and then work backwards to get Wednesday. Let's go. Wonderful. Did you get this answer? I'm certain you did. So we can say that Monday and Tuesday, the total fraction, 7/9. Yes, boys and girls? Is this the end of the sum? Oh, no, it's not. We still have to find out what fraction was done on Wednesday. Do you know what to do? Yes, I'm certain you do. We incorporate the whole again. What do? We subtract the 7/9 from our whole. I know you know what fraction to put. Yes, I'm hearing somebody say it. So on Wednesday, 2/9 of the kitchen floor was tiled. Boys and girls, please remember that fractions are beautiful. Adding and subtraction of fractions is not as difficult as you think it is. But with practice and revision, I think that you can master any problems involving addition and subtraction of fractions. Goodbye for now.